Right, now in this section we are still dealing with linear differential equations with constant coefficients. But this time we want to see what happens when the roots of the auxiliary equation are equal. So first of all, let's consider this. And by this I mean this particular expression here. Y equals bracket a plus bx close bracket e to the power nx. From this we can easily get a equal to y equals y times e to the minus nx minus bx. And differentiating, the left-hand side will be 0 because a is a constant, and the right-hand side will become e to the minus nx times dy dx minus ny e to the minus nx minus b. That gets us that far. So that b, making b the subject of that formula, b will equal e to the minus nx dy dx minus ny e to the minus nx, and simplifying that by just taking the e to the minus nx outside, we get e to the minus nx bracket dy dx minus ny. So we're down to here. So differentiating a second time, we'll get 0 on the left-hand side because b is a constant, and on the right-hand side we'll get this expression here, e to the minus nx bracket d2y dx squared minus n dy dx close bracket minus n times e to the minus x bracket dy dx minus ny. We can now get rid of the factor e to the minus nx because when you divide or multiply by e to the minus nx, you still get 0 on the left-hand side, and on the right-hand side, after simplifying, you'll get this equation here, d2y dx squared minus 2n dy dx plus n squared. Now, if you look at that particular equation, the auxiliary equation for it is m squared minus 2nm plus n squared, which is, the left-hand side is just m minus n all squared. Okay, and the roots are equal. So in this case, the solution, just reversing the process, will be y equals a plus bx e to the nx. All right, so let's just take a look at some examples. So first of all, find the general solution to the equation d2y dx squared minus 6 dy dx plus 9 equals 0. The auxiliary equation is m squared minus 6m plus 9. And when you factorize that, that's m minus 3 all squared equals 0. So the roots are equal. So we're down to here. This means the general solution now will be y equals a plus bx times e to the power 3x. Do another example. This time have a third order equation, and we want to find the general solution to the equation d3y dx cubed minus 12 dy dx plus 16y equals 0. So we're down to here. The auxiliary equation is m cubed minus 12m plus 16. And when you factorize that, you will get m minus 2 all squared times m plus 4 equals 0. So the roots are minus 4, 2, and 2. And the general solution will be y equals a e to the minus 4x plus bracket bx plus c times e to the power 2x. And that should be fairly clear. So I've given you some practice examples here, and I'll just leave this running for you to write them down. You shouldn't have too much difficulty with them, but good luck with them anyway. The next section we'll see what happens when we get imaginary roots for the auxiliary equation.